Question 1. Why is the Earth spherical? A. Because of the impact of meteorites grinding it into a circular shape. B. Because of the surface tension of the water on Earth. C. Because of the force of gravity. D. Because all planets are spherical. The answer is C. Because of the force of gravity. Explanation. The Earth, or pulled down, our planet, it's the third planet surrounding our Sun called the Sol, and it's roughly a circular shape because of the gravitational field pulling everything into the centre. So the actual forces are such that mountains of a certain height get contracted or pulled down. Its bulge is a little bit in the centre due to the rotation, but it's a largely circular shape because of gravitational. Question 2. What distance have scientists agreed on as defining outer space as opposed to the atmosphere? A. 100 kilometres. B. 200 kilometres. C. 50 kilometres. D. 10 kilometres. The answer is A. 100 kilometres. Explanation. The atmosphere on Earth is held in by Earth's gravitational field, and the pressure of the atmosphere is due to the amount of atmosphere on top of each one. So each metre has the effect of another metre above it. So we've got the actual weight of the atmosphere causes the atmospheric pressure. But even so, the atmosphere eventually runs out around 100 kilometres out as it exponentially thins out. Question 3. What causes a rocket to move forward? A. The rocket engine pushing against the atmosphere. B. The heat and flame from the rocket engine. C. The force against its rocket fuel. D. The rocket engine pushing about against the ground. The answer is C. The force against its rocket fuel. Explanation. We get spaceships, space stations into space by having a force engine, and this produces force by applying a force to the rocket fuel, which is expanding, and that rocket fuel applies an equal and opposite force to the rocket, pushing it up. And the speed of the rocket, or the amount of force, is proportional to the amount of rocket fuel burnt and the relative velocity of the fuel to the rocket itself. Question 4. How do rockets launch into orbit? A. They turn and accelerate horizontal to the ground. B. They burn their engines for at least 20 minutes. C. They go to ever higher altitudes. D. They travel up until they pass the atmosphere. answer is A. They turn and accelerate horizontal to the ground. Explanation. Around 10 kilometres in the stratosphere above the cloud, it undergoes a gravity roll and starts to accelerate more or less parallel at a slight angle to the Earth's surface. This is called a gravity roll, and the main thing is to increase its velocity relative to a point on the ground. It's distance covered with respect to the ground to reach an orbital speed. Question 5. Where is the International Space Station? A. Orbiting 400 kilometers surface. B. Houston, Texas. C. Orbiting 3,000 kilometers above the Earth's surface. D. Orbiting 200 kilometers above the Earth's surface. The answer is A. Orbiting 400 kilometers above the Earth's surface. Explanation. The International Space Station is in an orbit some 380 to 450 kilometers above Earth. It slowly decays with collisions with a very thin atmosphere up at that altitude. From time to time, booster rockets increase its altitude, increases its speed and altitude. Question 6. What best describes the size of the International Space Station? A. The size of an airship like the Hindenburg. B. The size of a garden shed. C. The size of a football stadium. D. 3 large rooms stuck together. The answer is D. 3 large rooms stuck together. Explanation. The International Space Station is roughly the size of 3 connected classrooms. The size of a classroom, multiply that by 3. It's essentially basically half the space, is about half the passenger area of a large commercial airliner. In fact, its length is a little bit longer than a Boeing 747, but essentially that's mostly solar panels across, and there are 3 major modules stuck to each other. You may have walked through it in the Powerhouse Museum. So it's not all that big. It's actually quite small. And attached to it are some Sawyer return capsules which lock onto it. So it's actually quite small up in space. Question 7. What is the air pressure inside the International Space Station? A. 1 atmosphere of a 1/5 oxygen, 4/5 helium gas. B. Half an atmosphere of oxygen and helium equally. C. 1 atmosphere of a 1/5 oxygen, 4/5 nitrogen. D. 1/5 of an atmosphere of pure oxygen. The answer is D. 1/5 of an atmosphere of pure oxygen. Explanation. The International Space Station maintains habitable life by providing an atmosphere for the astronauts. Now, the higher the pressure you have, so it's an atmosphere inside and vacuum outside, so the greater the pressure difference to the atmosphere, the thicker the walls you require. So to get around this, they have in the space station just pure oxygen at about a fifth of the atmosphere that you breathe on Earth. So the walls are very, very thin because they don't have to have very high pressure gas because there's no nitrogen in. Question 8. Compared to being on the surface of the Earth, astronauts in the International Space Station are exposed to which type of radiation? A. Cosmic rays only. B. Solar wind only. C. Cosmic rays and the solar wind. D. Cosmic rays, the solar wind and radioactive material from their fuel cells. The answer is A. Cosmic rays only. Explanation. Space is a very radioactive, space has a large amount of lethal radiation in it. Most of it comes from the sun and does not reach Earth because it's swept around by a magnetic field into these space belts called the Van Allen belts. So when they first sent rockets high up above the orbit of the space station, they encountered these radiation belts. But even coming through that are cosmic rays, and cosmic rays generally hit the surface of our atmosphere and cause showers of particles, neutrons and muons. These are heavy electrons to shower down on us all the time, meaning that a lot of the brute energy of the cosmic rays is absorbed, but we still get quite a lot of cosmic radiation down here on Earth. You have to actually travel a fair number of meters, about 50 meters underground, before there's very little, or not 50, 30 meters underground before you get no radiation from space hitting us. And so, in fact, if you have a rock on Earth and it's facing upwards, it cooks on the surface, and eventually, as you turn it over, if something turns it over, it starts to cook again. So you can see rocks, two rocks next to each other, one rock which has been turned over many thousands of years ago. You can actually date the point at the time when someone picked up that rock and turned it over. A simple thing like this, because you can measure the cosmic radiation going in the space station. Although it's protected from the Van Allen belt, from solar wind, it's not protected from cosmic rays. Question 9. The recent depressurization of the International Space Station was caused by A. a computer malfunction, B. a sabotage drill hole, C. a valve malfunction, D. a small meteorite. The answer is B. a sabotage drill hole. The explanation. The International Space Station recently had a degassing emergency where its atmosphere was rushing out into space after doing a search, and where they closed individual portals to see where it was coming from. They identified it as a 2mm drill hole of sabotage in the one of the Soviets or Russian return to Earth, emergency return to Earth capsules. Question 10. Currently, only the Russians have the capability of visiting the International Space Station, but by 2020, the US hopes to have Boeing's Starliner B, to have Elon Musk's Falcon heavy lifting rocket, C, to have two options of Elon Musk and Boeing, D, have three options, the Russians, Elon Musk and Boeing. The answer is D. Have three options, the Russians, Elon Musk and Boeing. Explanation. Since the last space vehicle on it in 2011, the United States have been reliant on Russia to supply refueling of their space station and transport of their astronauts. But by 2020, they hope to have three options available. One is the use of the Russians. The other is the use of Elon Musk's Falcon heavy lifting rockets with a space probe on it, a space vehicle on it, and another one by Boeing. So the US have funded two development companies, which is a standard thing to do when they have military contracts. They give up two military contracts to two companies to develop the